A very good morning. Welcome to the next session of determinants. Today we will study adjoint of a matrix, inverse of a matrix and solution of system of linear equations using inverse of a matrix. ये जो हमारा लास्ट टॉपिक है ये मोस्ट इंपॉर्टेंट टॉपिक होता है क्लास 12 का, जिसपे बेस्ड क्वेश्चन आपको हमेशा मिलता ही मिलता है। सबसे पहले शुरू करते हैं adjoint of a matrix. The adjoint of a square matrix A is defined as Aij n cross n is defined as the transpose of the matrix capital Aij n cross n. ये जो कैपिटल Aij है ये कोफैक्टर होगा Aij का। अब शॉर्टकट में आप इसे ऐसे याद रख सकते हैं कि एडजॉइंट जो है आपका किसी भी मैट्रिक्स का उसके कोफैक्टर्स के ट्रांसपोज का मैट्रिक्स होगा। कोफैक्टर मैट्रिक्स जो बनेगा उसका अगर आप ट्रांसपोज लेते हैं तो आपको एडजॉइंट ऑफ ए मिलेगा। लेट मी गिव यू एन एग्जांपल एंड ट्राई टू अंडरस्टैंड इट बाय द एग्जांपल ओनली कि अगर आपको ए मैट्रिक्स हमने दिया 2 1 3 5 ये 4 एलिमेंट्स हैं। सबसे पहली कंडीशन यहां मैं बताऊं आपको, मैंने अंडरलाइन की कि आपका जो मैट्रिक्स होना चाहिए जिसका आप एडजॉइंट फाइंड कर रहे हैं इट शुड बी अ स्क्वायर मैट्रिक्स। वो मैट्रिक्स आपका स्क्वायर होगा। फाइन। अब देखिए सबसे पहला काम होगा इसके सारे कोफैक्टर्स फाइंड कर लो। A11 कोफैक्टर जो होगा हमने पिछले वीडियो में किया था कोफैक्टर्स फाइंड करना। -1 रेज टू द पावर 2 फर्स्ट रो और फर्स्ट कॉलम को कैंसिल करो तो यहां आपको 5 मिलेगा। A12 ये आपको -1 पावर 3 फर्स्ट रो सेकेंड कॉलम को कैंसिल करो 3। A21 दिस A21 इज -1 raised to the power 3 second row first column into 1 and A22 it is -1 raised to the power 4 second row second column यहाँ कितना आ गया आपके पास 2। तो यहाँ देखिए ये वैल्यू आपको मिलेगी 5, ये वैल्यू आपकी हो जाएगी -3, this is your -1 and this is your 2। तो यहां से एक मैट्रिक्स मैं लिखता हूं पहले आपके लिए, कोफैक्टर मैट्रिक्स ऑफ ए। उसमें आपके एलिमेंट्स ऐसे होंगे A11 A12 A21 A22। तो यहां एलिमेंट्स आपको मिले 5 -3 -1 and 2। नाउ इन ऑर्डर टू राइट द adjoint of this matrix, adjoint of A ADJ, इससे हम adjoint को डिनोट करते हैं। adjoint of A it is transpose of this matrix। तो अगर आप इसका ट्रांसपोज लोगे तो फर्स्ट रो आपका फर्स्ट कॉलम में चेंज होगा और सेकेंड रो आपका सेकेंड कॉलम में चेंज होगा। सो दिस इज हाउ डू वी राइट एडजॉइंट ऑफ अ मैट्रिक्स। एडजॉइंट कैसे मिलेगा? कोफैक्टर्स फाइंड करके उसका ट्रांसपोज ले लो, यू विल गेट द एडजॉइंट ऑफ अ मैट्रिक्स। नाउ वी विल फाइंड द एडजॉइंट of a 3x3 matrix. For adjoint, we need to first of all find the cofactors. So your A11, it is equals to -1 raised to the power 2. First row, first column को हम कैंसिल करेंगे, क्या मिलेगा हमें? 3 5 0 1। So it will give you 1 into 3 minus 0 which is equals to 3. Now next is A12 which is -1 raised to the power 3. अब इसमें हम फर्स्ट रो और सेकेंड कॉलम को कैंसिल करेंगे, so we will get 2 5 -2 1। यहां आपको मिलेगा -2 + 10 that is -12। Then we will have A13 which is -1 raised to the power 4 first row and third column. So we will have 2 3 minus 2 0. So we will get 1 into 0 plus 6, which is equals to 6. Next we have a 2 1, which is your minus 1 raised to the power 3. Now this time we will cancel second row and first column. So we will have minus 1 2 and 0 1. So we will get negative of 1, negative 0. So this will give you 1. Here you have 6. This one was minus 12 and this is your 3. Now after this I have a 2 2, which is minus 1 raised to the power 4. Second row and second column I'll cancel. So I'll be having 1 2 minus 2 1. So this will give me 1 plus 4, which is equals to 5. Next I have a 2 3, which is minus 1 raised to the power 5, and second row third column. So you have 1 minus 2 0. So it will give you negative 0 minus 2, which is equals to 2. After this I have a 3 1, which is minus 1 raised to the power 4, and third row first column, that means minus 1 2 3 5. So this gives you 1 into minus 5 minus 6, which is equals to minus 11. Then I have a 3 2. So a 3 2 is your minus 1 raised to the power 5. Third row and second column I will cancel. I will be having 1 2 2 5. Third row second column. Then I will have minus 5 minus 4. So it is your negative of 1. Here you have negative 11. Now the last cofactor is your a 3 3. It is minus 1 raised to the power 6. Third row and third column you will cancel. You will be having 1 minus 1 2 3. So this will give you 1 into 3 plus 2, which is equals to 5. So after finding the cofactors, you can write a cofactor matrix of A, which will give you 3, and the second element is minus 12, then 6, then you have 1 5 2, then minus 11 minus 1 and 5. Now from here you can write adjoint. Your adjoint of A is the transpose of this matrix. So it will give you 3 minus 12 6 1 5 2 and minus 11 minus 1 5. So this is how you can find the adjoint of a 3 cross 3 matrix. Now we have certain very important definitions as well as some theorems for you. The first theorem: if A be any square matrix of order n, then A into adjoint of A into A, it is equals to determinant of A into I. Let me tell you this by an example. Ki if they'll give me a matrix A like this, and they'll ask you to find A into adjoint A. Fine. Now in order to find A into adjoint A, it is not necessary कि मैं पहले adjoint A को find करूं फिर उसको A से multiply करूं. I can directly use this result. How? First of all, I will find determinant of A, और determinant of A यहाँ हमें मिलेगा 15 minus 2, that is 13. So I know the result A into adjoint A, it is equals to determinant of A into I. आई हमारा आइडेंटिटी मैट्रिक्स होगा और उसी ऑर्डर का जिस ऑर्डर का आपका ए मैट्रिक्स है। तो यहां डिटर्मिनेंट ए आपको मिला 13 और उसके साथ आई आप लिख देंगे 1 0 0 1। सो योर ए इंटू एडजॉइंट ए you will get as 13 0 0 13. Next we have, if A and B are non-singular matrices of same order, then AB and BA are also non-singular matrices of same order. मैंने एक नॉन सिंगुलर की डेफिनेशन आपको बताई थी इन द प्रीवियस वीडियो कि एक मैट्रिक्स हमारा नॉन सिंगुलर होगा इफ डिटर्मिनेंट ऑफ ए इज नॉट इक्वल्स टू 0। इसका मतलब अगर मेरे पास डिटर्मिनेंट ए नॉट इक्वल्स टू 0 है, डिटर्मिनेंट बी नॉट इक्वल्स टू 0 है, तो हमारे पास ए बी जो होगा, डिटर्मिनेंट ऑफ ए बी वो भी आपका नॉट इक्वल्स टू 0 होगा। फाइन। और डिटर्मिनेंट ऑफ बी ए जो है वो भी हमारा नॉट इक्वल्स टू 0 होगा। दिस इज व्हाट दिस थ्योरम सेज कि A and B are non-singular matrices of same order, then AB and BA they are also non-singular matrices of same order. Third theorem, the determinant of the product of matrices is equal to the product of their respective determinants. For example, if they'll give me a question that determinant of A is equals to 5 and determinant of B is equals to 6, then what is the determinant of AB? Then this determinant of AB is equals to determinant of A into determinant of B, that is your 5 into 6, which is equals to 30. Now very special note I have written over here that determinant of adjoint A, it is equals to determinant of A raised to the power n minus 1. This is the thing you have to keep in mind. Now if I'll give you that A is a matrix whose determinant it is equals to 5 and order of A is 3 cross 3. So this order denotes your n. N is what? 3. Now they'll ask you find determinant of adjoint A. So this determinant of adjoint A, it is equals to determinant of A raised to the power n minus 1, where n is the order of the matrix. I should write here n is order of A. So this will come out to be determinant of A raised to the power 3 minus 1. That is determinant of A raised to the power 2. So in this case it will become your 5 raised to the power 2, which is equals to 25. So in this way you can use this theorem also. If A is a square matrix, A is invertible if and only if A is non-singular. What does it mean? That inverse exists only for non-singular matrices. Non-singular matrices means if your determinant of A is not equals to 0, then only A inverse exists. So they may ask you a question in this way that a matrix is given like 6 2. Now I'll ask you, check whether A inverse exists or not. So you'll simply find the determinant of this matrix, and since the determinant will came out to be 6 minus 6, which is equals to 0, so you will say determinant of A is equals to 0, therefore matrix A is singular, therefore A inverse does not exist. What does it mean? कि determinant if it came out to be 0, then A inverse does not exist. Inverse exists only in the case when your determinant of a matrix is not equals to 0. The last result is regarding the value of A inverse. A inverse has the value 1 by determinant of A into adjoint of A. So if we are being given with a matrix A 3, 2, 5, 7 and they'll ask you to find A inverse. So my first step would be that first of all I'll find the determinant of A in order to check whether the inverse exists or not. So that I'll do using 21 minus 10, it is equals to 11. Since determinant of A is not equals to 0, therefore A inverse exists. Now I'll find adjoint A. So for adjoint A, I'll find the cofactors. So your cofactors will be A11, that is minus 1 square. First row, first column, I'll cancel 7. So answer will be 7. Your A12, it is equals to first row, second column, minus 1 raised to the power 3 into 5. So it is equals to minus 5. Then we have A21, second row, first column, minus 1 raised to the power 3. Second row, first column will give you 2. And then A22, minus 1 raised to the power 4. Second row, second column, it is 3. So answer will be 3. So point A is the transpose of the cofactor matrix. So you will get 7 minus 5, 2, 3. So this is the adjoint A. Now you can write A inverse. It is equals to 1 by determinant of A into adjoint of A. So determinant A is how much? 11. So you'll write 1 by 11 into minus 5, 3. So this is the value of your A inverse. Need not to take this 11 inside, you can write it as it is. I have taken one question 12 from exercise 4.5. If A is equals to 3, 7, 2, 5, it is a 2 cross 2 matrix and B is also a 2 cross 2 matrix. Then I have to verify AB inverse is equals to B inverse into A inverse. Here they have given this result to verify, but you can use this result in your some competitive exams directly, that AB inverse is equals to B inverse into A inverse. Fine. So here first of all I have to find determinant of A. So your determinant of A is how much? 15 minus 14, which is equals to 1. Now cofactors of A. So cofactors of A is your A11, that is first row, first column cancelled, 5. A12, first row, second column cancelled, minus 2, minus because this sum is odd. A21, negative, second row, first column, 7. Then A22, second row, second column, it is 3. So your adjoint A, it is the transpose of the cofactors. So I'll directly take the transpose, 5, minus 2, minus 7 and 3. Similarly, I'll find the adjoint of B as transpose of the cofactors, that is 9, minus 7 and minus 8, 6. So now you can write A inverse. Your A inverse is 1 upon determinant of A into adjoint A. So this you will get 1 upon 1 into what is adjoint A? 5 minus 7 minus 2, 3. So this is the value of your A inverse. A inverse is 5 minus 7 minus 2 and 3. Now I'll be writing B inverse. B inverse is 1 upon determinant of B into adjoint of B. So you can write 1 upon determinant of B. Determinant of B is minus 1, minus 2. So 1 upon minus 2, and in adjoint B I'll be writing 9 minus 8 minus 7, 6. So I'll take this negative sign inside. I'll be having 1 by 2 minus 9, 8, 7 and minus 6. This is B inverse. Fine. Now your right hand side is B inverse into A inverse. So this also you can find B inverse into A inverse. So it will be 1B. So once you multiply, you will get first row, first column. So this is my B inverse into A inverse. Fine. Now for left hand side, I'll take first of all A into B. So my A is 3, 7, 2, 5 and my B is 6, 8, 7, 9. So determinant of AB. Here I can use the result. Determinant of AB, it is equals to determinant of A into determinant of B. The theorem that I told you. Fine. So you'll be having 1 into minus 2, it is equals to minus 2. Now you can find the cofactors of AB and they will be A11, it is first row, first column cancelled 61, A12, first row, second column cancelled minus 47, A21, second row, first column minus 87 and A22, it is second row, second column 67. Now you can write adjoint of AB. So your adjoint of AB came out to be how much? You can just take the transpose 61 minus 47 and then minus 87 and 67. So your AB inverse, it is equals to 1 upon determinant of AB into adjoint of AB. So this came out to be minus 1 by 2, 61, minus 87, minus 47 and 67. Now if you take this negative inside, your AB inverse, it is equals to 1 by 2, negative 61, 87, 47 and minus 67, which is equals to your B inverse into A inverse. Hence we have verified that my AB inverse, it is equals to B inverse into A inverse. We have another example of exercise 4.5, question number 13. A is given a 2 cross 2 matrix. You have to show A square minus 5A plus 7I is equals to 0. And then you have to find A inverse. Fine. So this type of questions you have done in the 3rd chapter, where you have to show that this matrix equation gives the result 0. So let me solve. A square means A into A, which is 3, 1, minus 1, 2 and 3, 1, minus 1, 2. So it will give you 9 minus 1, 8, 3 plus 2, 5, minus 3 minus 2, minus 5, and then minus 1 plus 4 is 3. This is your A square. Now you can find 5A. So your 5A is multiplying A by 5. You'll get 15, 5, minus 5 and 10. Now last you need 7I. 7I means multiplying your identity matrix by 7. So you'll get 7, 0, 0, 7. Now let me find the values. A square minus 5A plus 7I. So your A square is 8, 5, minus 5, 3, minus 5A is yours 15, 5, minus 5 and 10, and 7I is your 7, 0, 0, 7. Now on adding these three matrices, we will get 8 minus 15 plus 7. Second element I'll get 5 minus 5 plus 0. Third element is my minus 5. This minus minus will become plus 5, and the last one is 0. Last element I have 3 minus 10 and plus 7. So just check it out. 8 plus 7, 15 minus 15, 0. This is also 0. This is also 0, and this is 0. So I have proved that a square minus 5a plus 7i is equals to 0. Now there is important question. You have to find a inverse. This a inverse you have to find using this equation only. A square minus 5a plus 7i is equals to 0. Now pre-multiplying whole equation by a inverse. If I multiply this whole equation by a inverse, I'll get a inverse into a square minus 5 a inverse into a plus 7 a inverse into I is equals to 0. Now I can write a inverse into a. This a square I have broken into two parts. Now minus 5 a inverse into a and plus 7 a inverse into I is equals to 0. Now in 3.4 we have done a result that my a inverse into a, it is always a identity matrix. जब भी हम किसी मैट्रिक्स को उसके इनवर्स से मल्टीप्लाई करेंगे तो आंसर हमें आइडेंटिटी मिलेगा. दूसरा एक रिजल्ट हमने किया था कि अगर हम किसी भी मैट्रिक्स को आइडेंटिटी से मल्टीप्लाई करते हैं तो हमें सेम मैट्रिक्स वापस मिल जाता है. Using these two results, I'll get I into a minus 5i plus 7a inverse, it is equals to 0. So from here 7a inverse is equals to, इन दोनों को मैंने उधर शिफ्ट किया, 5i माइनस i इंटू a हमारा a हो जाएगा a. तो यहां से what will you get, आपको 7a इनवर्स की वैल्यू मिल गई. 7a इनवर्स इज इक्वल्स टू 5i. 5i का मतलब आइडेंटिटी मैट्रिक्स को हम 5 से मल्टीप्लाई कर लेंगे. वी विल गेट दिस माइनस a. a आपको क्वेश्चन में गिवन है 3 1 माइनस 1 2. आप सिंप्लीफाई करोगे तो आपको मिलता है यहां पर 5 minus 3 is 2, 0 minus 1 minus 1, 0 plus 1 1, and 5 minus 2 is again 3. So your 7a inverse came out to be 2 minus 1 1 3. Now from here you will get the value of a inverse, which is 1 by 7 2 minus 1 1 3. Fine. So this is a very important question in which we are using the concept of the third chapter, as well as we are finding this inverse using this equation only. So you need to keep in mind, if a equation is given and then they are asking you to find the a inverse, then you are not supposed to use that method of adjoint and then finding the a inverse. You'll have to use this equation only. Last topic of this chapter, solution of system of linear equations using inverse of a matrix. This is the application of determinant that we are going to do. हमें यहाँ पर तीन इक्वेशंस गिवन होंगी x, y और z में. ये लीनियर इक्वेशन इन 3 वेरिएबल्स हैं हमारे पास. इन इक्वेशंस को मैं मैट्रिक्स इक्वेशन में चेंज करूंगा पहले, देन आई विल ट्राई टू फाइंड द वैल्यूज ऑफ x, y एंड z. So first of all I'll write matrix A. Matrix A हम लिखेंगे और matrix A में हम कोफिशिएंट्स लिखेंगे x, y, z के. A11, A12, A13. फर्स्ट कॉलम में कोफिशिएंट ऑफ x, सेकेंड कॉलम में कोफिशिएंट ऑफ y, थर्ड कॉलम में कोफिशिएंट ऑफ z. A21, A22, A23. A31, A32, A33. Now you will write another matrix B in which I'll write these constants on the right hand side, that is d1, d2, d3. And then I'll write a column matrix X which will contain the variables X, Y and Z. Now I'll try to show that these three matrices, they will form a matrix equation AX is equals to B. A is your A11, A12, A13, A21, A22, A23, A31, A32, A33. And your X is X, Y and Z. And your B is D1, D2, D3. Now see the magic of your matrices. If you multiply first row first column, आपको मिलेगा A11X plus A12Y plus A13Z. Second row first column, A21X, A22Y, A23Z. A31X, A32Y, A33Z. ये तीन एलिमेंट्स आपको मिले लेफ्ट हैंड साइड पे. राइट हैंड साइड यू हैव D1, D2, D3. नाउ यू कैन विजुअलाइज दो मैट्रिसेस हमारे इक्वल हैं तो इनके कोरेस्पॉन्डिंग एलिमेंट्स क्या होंगे? इक्वल. इसका मतलब A11X, A12Y, A13Z, A11X प्लस A12Y प्लस A13Z, ये किसके इक्वल होगा? D1 के, जो कि आपको फर्स्ट इक्वेशन मिलेगी. A21X, A22Y, A23Z, it is equals to D2. A31X, A32Y, A33Z is equals to D3. तो देखिए आपको इस मैट्रिक्स इक्वेशन से ये तीनों आपकी जो लीनियर इक्वेशन इन थ्री वेरिएबल्स थी वापस मिल गई. व्हाट डज इट मीन कि इन एल्जेब्रिक इक्वेशंस को हम इस मैट्रिक्स इक्वेशन की फॉर्म में भी लिख सकते हैं. एज वी हैव सीन कि ये मैट्रिक्स इक्वेशंस जो है आपकी, ये इस एल्जेब्रिक इक्वेशंस को, पेयर ऑफ एल्जेब्रिक इक्वेशन को रिजेंबल करती हैं. नाउ वी हैव सम डिफरेंट केसेस. केस 1 में लेता हूं आपके पास कि अगर हमारा A नॉन सिंगुलर है. नॉन सिंगुलर का मतलब डिटर्मिनेंट ऑफ A हमारा नॉट इक्वल्स टू 0 है, जिसका मतलब होगा कि A इनवर्स आपका एग्जिस्ट करेगा. तो वहां से आप क्या कर सकते हैं? इस AX इज इक्वल्स टू B, इस मैट्रिक्स इक्वेशन को A इनवर्स से मल्टीप्लाई कर सकते हैं, क्योंकि A इनवर्स हमारा एग्जिस्ट करेगा, जैसा अभी मैंने पिछले एग्जाम्पल में आपको करके दिखाया था. तो you will get A inverse into AX, it is equals to A inverse into B. Now A inverse into A, it is equals to I into X is equals to A inverse into B. Now your X is equals to A inverse into B. तो X आपके पास क्या था? X, Y, Z. और यहाँ A इनवर्स, जब आपको मैट्रिक्स A मालूम होगा तो आप उसके कोफैक्टर्स और एडजॉइंट फाइंड करके आप उसका A इनवर्स फाइंड कर लेंगे. और B मैट्रिक्स आपको मालूम है क्या है आपके पास? D1, D2, D3. व्हाट डज इट मीन कि अगर हम इन इक्वेशंस को सॉल्व करें तो वहां से हमें X, Y और Z की वैल्यूज मिल जाएंगी. Now case second we have, if A is a singular matrix, singular matrix means determinant A हमारा क्या होगा? 0. तो उस केस में हम लोग adjoint A into B कैलकुलेट करेंगे. अगर आपका adjoint A into B 0 आ जाता है, then we say the solution does not exist and system of equation is inconsistent. In case अगर मेरा adjoint A into B not equals to 0 आता है, in that case I'll say that system may be either consistent or inconsistent. depending on whether the system of equations, this system of equations, it has infinite number of solutions or no solutions. So on the basis of this, we can say that we can solve these three system of equations using your inverse of a matrix. आपके पास तीन केसेस अराइज होंगे. एक होगा आपके पास जिसमें आपका यूनिक सॉल्यूशन होगा, दूसरा आपके पास नो सॉल्यूशन और तीसरा आपके पास इनफाइनाइट नंबर ऑफ सॉल्यूशंस. लेट्स टेक एन एग्जांपल. सॉल्व द सिस्टम ऑफ इक्वेशंस यूजिंग मैट्रिक्स मेथड. मैट्रिक्स मेथड हमारे पास होता है कि हमें ऐसे सिस्टम ऑफ इक्वेशंस दे रखी हो. ए मैट्रिक्स हम बनाते हैं एक्स वाई जेड के कोफिशिएंट से, बी मैट्रिक्स होगा हमारे कांस्टेंट्स और एक्स मैट्रिक्स होगा हमारे पास जो वेरिएबल्स हैं उनसे. लेटर ऑन वी कैन यूज एक्स इज इक्वल्स टू ए इनवर्स इनटू बी. सो द मेथड इन विच वी यूज दिस मैट्रिक्स इक्वेशन इज कॉल्ड योर मैट्रिक्स मेथड. नाउ लेट्स सॉल्व दिस क्वेश्चन बाय मैट्रिक्स मेथड. सबसे पहले हम लोग मैट्रिक्स ए लिखेंगे. मैट्रिक्स ए में x के कोफिशिएंट्स फर्स्ट कॉलम में, y के कोफिशिएंट्स सेकेंड कॉलम में. उसके बाद मैट्रिक्स B लिखोगे आप, जिसमें आप कांस्टेंट्स लिखोगे. आपके पास यहाँ कांस्टेंट है 1 और 7. फिर आप मैट्रिक्स X लिखोगे जिसमें आप वेरिएबल्स लिखोगे. यू हैव x एंड y. अब यहां मेरे पास सबसे इंपॉर्टेंट पार्ट है, आई नीड A इनवर्स. तो A इनवर्स हमने अभी पीछे फाइंड करना सीखा था, उसी प्रोसेस से हम लोग फाइंड करेंगे. A इनवर्स एग्जिस्ट करेगा व्हेन डिटर्मिनेंट ऑफ A इज नॉट इक्वल्स टू 0. तो लेट्स चेक डिटर्मिनेंट ऑफ A. 4 minus 15 is equals to minus 11. So since your determinant of A is not equals to 0, this implies A inverse exists. अब A इनवर्स के लिए मुझे कोफैक्टर्स चाहिए. सो लेट्स फाइंड द कोफैक्टर्स. A 1 1, फर्स्ट रो फर्स्ट कॉलम कैंसिल्ड, यू विल गेट 2. A 1 2, फर्स्ट रो सेकेंड कॉलम, यू विल गेट -3. A 2 1, second row first column you will be having -5, and then A 2 2, it is second row second column, you will be having 2. Now you can write adjoint from here. Adjoint of A, cofactors का transpose. 2 -3 -5 2. Now you can write A inverse using the formula 1 upon determinant of A into adjoint of A. So you can write here 1 upon -11 and then 2 -5 -3 2. You can take this negative inside 1 upon 11 and then you will be having -2 5 3 -2. आप इस 11 को अंदर मत ले जाइएगा. Need not to make the fraction. We will use it later on. Now I'll just substitute the values here. My x is x into y. A inverse is 1 by 11 -2 5 3 -2. And in place of B I have the constants 1 and 7. So I'll multiply these two matrices. I'll get the two values. First row first column I'll have -2 plus 35. Then first row second row first column I'll get 3 minus 14. So I'll be having as xy and then 1 by 11. This will give you 35 minus 2 is 33, and here you'll be having -11. So just dividing by 11 you will get x is equals to 3 and y is equals to -1. So this system of equations we have solved using your matrix method. This is how do we find the solutions of the system of equations. So if you are being, this is an example for 2 cross 2 matrix, or when the equation contains two variables only, x and y. The same problem you can solve for the variables x, y and z also. In that case you will get here 3 cross 3 matrix and you will find its determinant, then you will find its cofactors. here in this exercise, cofactors plays a very important role that we have done in the third exercise, sorry. So if you know how to find the cofactors, then you can solve these questions very easily. Thank you.